In example number 6, we have a submersible, which is kind of like a submarine, something that explores the ocean floor. It begins to ascend to the surface. The elevation h, for height, in feet of the submersible is modeled by the function h of t is equal to 650t minus 13,000, where t is the time in minutes since the submersible began to ascend. We want to graph the function and identify its domain and range. And second, we want to interpret the slope and intercepts, the slope and the intercepts of the graph. So there are some new things in this problem that we haven't talked about yet, and one of them is this term function. Now, a function is a mathematical object, or it's a mathematical concept, and it has some definitions, some terminology, it has some notation with it as well. So the first type of notation that we're going to see with a function is this part on the left here. And we read this as h of t. So h of t is a function definition. This is unlike an equation where the two sides are equal to each other. What we have here is a function definition. And the name of this function is h for height. And what we mean by function is that the height of this submersible at any time, or would actually be the height below the surface of the water, or the depth below the surface of the water, is a function of the time since the submersible began to ascend. So h of t is really no different than y. That's just like saying y is equal to 650t, and the t, of course, is just like our x. So it's almost, really for our purposes here, the same as if we had the function or the equation y is equal to 650x minus 13,000. So for our purposes, that's how we're going to view this particular function. Now, why is function important? Well, again, function is an input-output object. You give it an input and it gives you back an output. In this case, you're going to give it the time, and what it's going to give back is the depth of the submersible below the surface of the water. So once again, we say that h of t, why is this a function? Why is height a function of time? Because the depth of the submersible beneath the surface of the water is a function of the time since it began to ascend, which means its height, or in this case its depth, below the surface of the water is going to be dependent on how long it is since the submersible began its ascension there. Alright, so, and I don't want to confuse height and depth here. We're talking about height, but since it's below the water, our heights are going to be negative. If we were talking about depth, which is below, would be positive. So we're using the word height, but our numerical values are going to come out negative here. Now, another difficulty that we have in this graph is that we have to set up and label our axes, and it's very difficult to do that. One thing we can do is look at the y-intercept. We know that when t is equal to 0, 650 times t will be 0, and we'll get a height of negative 13,000. So the way we write that is h parentheses 0. 0 is the time that we are plugging into this function, and what we're getting back from that as a result is what is the height when time is 0. And so this tells us that the submersible is starting off at a depth, or at a height of negative 13,000 feet, or a depth of 13,000 feet below the surface of the water. Now, how would I scale my y-axis or my h-axis in this case? Since we have to go down to 13,000 and I only have 20 spaces to do that, it appears that I can only do this by thousands. My times, on the other hand, again, I'm not really sure when the submersible will reach the surface of the water. At that point, the problem basically is over. So what I can do is, instead of letting t equal 0, just like we did with intercepts, I could let the equation equal 0. In this case would be let y equal 0. So 650 t minus 13,000. And if I were going to solve this, what this is basically asking is, at what time does the submersible reach the surface of the water when its depth is 0 feet beneath the surface of the water? And by solving this for t, we'll have that answer. So what I would need to do is add 13,000 to both sides, and I would get 13,000 is equal to 650t. Divide both sides by 650, and what I would end up with is that t is equal to 20. So what that means then is that at 20 seconds, the height will be 0, which means it reaches the surface of the water. So in this particular case, the way that I would graph this function, which is our first task here, is to find the intercepts. That is, set t equal to 0 and solve for the height. That would be negative 13,000. The next thing is to set the height equal to 0 to find at what time the submersible reaches the surface of the water, and we found that that is at 20 seconds. And then I graph that there. I plot the line between those 2 points. So if I wanted to find out the height at any point, say at 8 minutes, then I would just simply go down from 8 minutes and over to whatever that height would be. In this case, we can't be perfectly sure. It looks like it's about 8,000, but I could actually plug in t is equal to 8, and I could confirm that, or confirm that it's close to that on my calculator. So I've graphed the function, and the next thing it asks for is to identify the domain and range. Now, the domain is a specific terminology related to functions. The domain is the set of all possible input values. Well, input values here are t. And we know that time in this sense can't be negative, so time is going to start from 0 and it's going to continue until the submersible reaches the surface of the water. So we would say that time is going to go from 0 to 20. That is the domain. The domain is from 0 to 20. The second thing it asks for is the range. And the range is a set of all possible output values. Those are our height values, our h values. And we can see that the height is going to go from negative 13,000 up to 0. And so that's what our range is. So the domain, the set of possible input values, is going to go from the starting time till the time that the submersible reaches the surface of the water at t equals 20. The range is the set of all possible output values for this function, and that's going to go from negative 13,000 at the ocean floor to 0, the surface of the water. The next thing this asks for is to interpret the slope. Well, looking at our equation, if we saw this as y is equal to 650x minus 13,000, the slope is equal to 650. And what does that mean in this case? It means that the submersible is rising at a rate of 650 feet per second. Sorry, that's 650 feet per minute. So the slope actually means something here. That's how fast the submersible is heading toward the surface of the water. The second thing we want to do is to interpret the intercepts. Well, we've seen the y-intercept here is the starting point. So the y-intercept tells us where the submersible begins to ascend from. The x-intercept tells us the time when the submersible reaches the surface of the water. So it's important to note that in a function like this, in a real-world application like this, that the slope has definite meaning in the context of the problem. In this case, the slope is 650, which tells us how fast the submersible is rising to the surface of the water. It's rising at a rate of 650 feet every minute. The y-intercept tells us the starting point beneath the surface, which would be the depth at the ocean floor of negative 13,000 feet. The x-intercept tells us the time at which the submersible reaches the surface of the water. So all of these things are very important, and we want to be able to analyze functions and their graphs, and to be able to interpret that type of information from the function and from their graphs there. And we could use this graph and this function to tell us at any point in time after it begins to ascend how many feet below the surface of the water it is. And so we put in a time, it'll give us back the height beneath the surface, or the depth, but it will be a negative value. So this is what we mean by functions here. And I will stop this video at this point.